Hey guys, welcome back to my channel. In this video I'll be teaching you bitwise operators in Python. Bitwise operators are just like regular operators, but regular operators are used for decimal numbers. Bitwise operators are used for binary numbers. If you want to learn more about bitwise operators, all you have to do is keep watching. And also, before you watch this video, make sure you have watched my previous video, Operators in Python. I'll leave a card to it just in case you haven't. Bitwise operators in Python. The first section of this video is binary numbers. Bitwise operators are just like the regular operators that you use every day. But there's one difference. Bitwise operators are used for binary numbers, while regular operators are used for decimal numbers. If you don't know what binary numbers are, here's something that'll help you. Let's convert the number 22 to binary. As a decimal number, 22 is, now we have to figure this out. So to fill in this table, we're going to see 10,000, there's no 10,000s in 22, so we're going to say 0 here. And 22 has no thousands, 22 has no hundreds, 22 has 2 tens, and 2 ones. That's why 22 as a decimal number is 22. Here, 22 has 1/16, and it has 0 8s, 1 4, 1 2, and 0 1s. This is why 22 in binary is 10110. This is what binary numbers are. The next section of this video is the bitwise AND operator. Here's how the bitwise AND operator works. To test this out, we're going to AND 64 and 32. 64 in binary is 10000000. 32 in binary is 100000. Here's what the bitwise AND operator, or the ampersand operator, does. This is our Python code, and this, I hope you know this, but if you don't, this is a comment, and comments are avoided by languages. So this is a line that Python will execute, but this line will get avoided. That's because there's a hashtag here, and this hashtag makes this a comment. This comment will let a user know that this file's name is main.py. Now our code is a equals 64, b equals 32, and then print a and b. So if we run this program with python 3 main.py, Python is going to do some calculations. So the AND operator just runs this code. 1 and 0 for this, and 0 and 1 for this. So if this returns false, then Python is going to say 0 for this. So the only way you could get a 1 is if both numbers, both digits, were 1. But that's not true here, so we're going to say 0. Now it's going to fill in a 0 here, and 0, 0, 0, and 0, and 0. So our output is going to be 0. This will output 0 because the binary number 0 converted to decimal is 0. The next operator I'm going to teach you is the OR operator. Here's how the bitwise OR operator works. To test this out, we're going to OR 64 and 32. 64 in binary is 10000000. 32 in binary is 100000. Here's what the bitwise OR operator, or the pipeline operator, does. Our code is a equals 64, b equals 32, print a or b. So if we run this program, Python is going to do some calculations again. This time, instead of 1 and 0, it's going to be 1 or 0. And remember, true is 1 and false is 0. So for this, we're going to get 1. Here we're going to get 1 again. Here we're going to get 0, 0, 0, 0, and 0. So our answer is going to be 1, 1, 0, 0, 0, 0, 0 in decimal. So to calculate this, we have to say, so this number has 0 1s, 0 2s, 0 4s, 0 8s, 0 16s, 132, and 164. So this number has to be 96. So our answer here, or our output, is going to be 96. This will output 96 because the binary number 1, 100, 000 converted to decimal is 96. The next operator I'm going to teach you is the bitwise right shift operator. Here's how the bitwise right shift operator works. To test this out, we're going to shift 64 to the right 2 times. 64 in binary is 10000000. Here's what the bitwise right shift operator does. So this is our code. A equals 64, print A shifted to the right 2 times. Now if we run this program, Python is going to do some calculations again. So you can think of this as shifting each digit of the binary number to the right 2 times. This can also be removing the last 2 digits of the number. So this is going to be 0, 0, 1, 0, 0, 0, 0. So these extra zeros, I just added these so I could fill up these cells of the table. But this is the actual number, 1, 0, 0, 0, 0. So our answer here is going to be 0 1s, 0 2s, 0 4s, 0 8s, and 116. So our answer is 16. So this will output 16 because the binary number 10,000 is 16. The last operator I'm going to teach you is the bitwise left shift operator. Here's how the bitwise left shift operator works. To test this out, we're going to shift 64 to the left 2 times. 64 in binary is 10000000. Here's what the bitwise left shift operator does. Our code is A equals 64, print A shifted to the left 2 times. So if we run this program, Python is going to do some more calculations. And this time, instead of removing the last 2 digits, it's gonna add 2 zeros to the end of the number. So our answer is gonna be 1, 0, 0, 0, 0, 0, 0, 0, 0. So the output of this program will be 256 because this number has 0 1s, 0 2s, 0 4s, 0 8s, 0 16s, 0 32s, 0 64s, 0 128s, and 1 256. So this will output 256 because the binary number 100 million is 256. So this is how you use the bitwise left shift operator. So I figured if you knew all these operators, you would automatically know the equals versions of them. But just in case you didn't, here's something that'll help you. So I'm going to create a variable called a and assign it to 64. Now, I'm going to assign it to the left shift of it, and I'm going to pass 100 here. So I'm shifting 64 to the left 100 times. So this is my result. So the binary version of this number is this long string. So if I create a string out of this, and then so this is a number I got. So just like splitting a list like this, you can also split strings. So to split this string, I'm going to say 0 minus 100 because we added 100 zeros to this number. So this is what we had before we shifted 64 to the left 100 times. So this, as a decimal number, should be 64. See? This is how you use the equals versions of these operators. The equals versions are this that I just used, and this for right shifts, and this for the AND equals for the AND operator, and this for the OR operator. And yeah, that's it for this video, and bye. I'm going to leave a link to the document featured in this video. The link is going to be in the description. If you want to practice bitwise operators on your computer, you can go ahead and open the link, download the file, open the file with a browser, and practice bitwise operators. Okay guys, that was it for this video. Be sure to like, subscribe, and comment down below if you have any questions or comments. Also, be sure to watch my next video, and thanks for watching.